Okay, so let's set a scene. I think almost everyone's had this moment. You're on vacation, waiting in the
The
shallows.
water's crystal clear, you're at the beach.
Exactly. And then you spot it. A bright orange sea star just sitting on the sand. It looks like a decorative rock almost.
And that impulse to just, you know, pick it up, it's almost magnetic.
Just for a quick photo, you hold it for a second, put it back gently. It sinks away. No harm, no foul. Or, well, so we think.
That is a big assumption. And looking at the marine biology reports we've pulled for today, that little interaction, it's very often a death sentence.
And that's really our mission for this deep dive. We're not just here to say, don't touch. We want to get into the why. Why is an animal that looks so tough, so rock-like, actually so incredibly fragile?
It really just comes down to a complete misunderstanding of their biology. We see them as, these tough, rigid things,
Right.
but they're actually these incredibly sensitive, open biological systems.
Okay, so let's start with the biggest one, breathing. I think most of us just assume they have gills somewhere, like a fish.
Tucked away, yeah, but they don't. No lungs and no traditional gills. Instead, they rely on these amazing structures called papulae.
Papulae. The sources describe them as dermal gills. What does that actually mean?
Okay, imagine your skin wasn't just skin, but was covered in thousands of microscopic, super thin-walled balloons.
So they breathe directly through their skin.
That's it. Oxygen from the seawater diffuses straight into their body fluid. Their entire surface is their breathing surface.
Wow, so their body is essentially one giant exposed lung.
That is the reality.
Yeah.
Which means the second you lift them out of the water, you're not just asking them to hold their breath.
No, you're coating their entire respiratory system in air.
And it collapses. The gas exchange just stops instantly.
One of the reports we read used a really intense analogy. It said lifting them out is like filling a human's lungs with water.
It's an immediate asphyxiation. And all that carbon dioxide starts building up in their tissues. It's toxic.
But this is where you always get the pushback, right? I only held it for 5 seconds. Does that short time really matter?
It matters a lot more than people hope. The data shows there's no real safe time out of water. Because those papulae are so delicate, the air dries them out almost instantly.
So even a few seconds can cause permanent tissue damage.
Exactly. Damage that doesn't just heal when you put them back.
Okay, so air is clearly the enemy. But what if I keep it underwater? I just want to, hold it or move it to a better spot for a picture.
Then you're running into a completely different problem. Let's call it the hardware problem. Sea stars are hydraulic machines.
Right. This is the part I found fascinating. They move using water pressure, not muscles like we do.
They do. They have a little intake valve on top. It's called a madreporite. They pull in seawater to pressurize a whole system of internal canals that power their tube feed.
So when I grab a sea star, I'm basically squeezing a complex water balloon.
You are.
Uh-huh.
Even what you think is gentle handling can rupture those tiny canals or just throw the whole pressure system out of whack.
And if that pressure system fails?
They can't move. And more importantly, they can't pry open the shells of the clams and mussels they eat. You're effectively starving them.
And that's all before we even talk about what's on our own hands.
Oh yeah, the chemical warfare part. Sunscreen, bug spray, hand sanitizer, even just the natural oils on our skin. Remember those porous skin gills we just talked about?
Since they're breathing through their skin, they're absorbing anything on my hand directly into their system.
And it can act like a chemical burn on their mucus layers.
The scariest part of this for me in all the research was the timeline of how this plays out. The sources call it the Walking Dead phenomenon.
And it's the reason people think touching them is harmless. See, sea stars have incredibly slow metabolisms.
So you handle one, you put it back, and it might even start to crawl away. It looks perfectly fine.
It looks fine to us. But the internal damage, the tissue drying out, the ruptured canals, the infection from our sunscreen, that's all just getting started.
It can take hours or even days for them to finally die from that one interaction.
By then, you're long gone. The photo's already posted. And the animal is, well, it's slowly disintegrating somewhere on the ocean floor.
So the takeaway here really seems pretty binary. There is just no safe way to handle them, is there?
None. It's observation only. Keep them submerged. Don't touch. Just look. They're wild animals, not vacation props.
It really forces you to rethink the whole idea of an innocent interaction with wildlife.
It does. And it kind of leaves us with a provocative thought to wrap up on.
What's that?
We know now that the real damage to a sea star happens days after we've already walked away. It just makes you wonder, how many other interactions we have with nature are we misjudging simply because the consequences aren't immediate?
Something to think about. Thanks for joining us for this deep dive.